3 months ago, I posted a video on this channel about a plant called duckweed. The video explained that duckweed, a small floating water plant that grows in ponds and slow-moving water across 6 continents, contains 45% protein by dry weight, doubles its biomass every 48 hours, and has been studied by NASA as a potential space crop for long-duration missions. The video reached 650,000 views, and the top-voted comment on that video, with over 1,200 likes, said this exactly, quote, "If it absorbs heavy metals, it is good for the water, not so much for human consumption," end quote. The commenter was correct. Duckweed is a hyperaccumulator. It pulls heavy metals, pesticides, and nitrates out of polluted water and concentrates them in its tissue. That is precisely why it is used in wastewater treatment systems. Eating wild duckweed from a random pond is a legitimately bad idea. So for the last 30 days, I grew duckweed in a controlled home system, fermented it into kimchi, ate it every single day, and got a full heavy metals blood panel done before and after. This video is the sequel the comment section demanded, and the results are going to change your mind about one of the most suppressed protein sources on Earth. Here is the part nobody is telling you. Lactobacillus bacteria, the microbes responsible for every lacto-fermented food in human history, specifically bind heavy metals. A 2016 study in Applied and Environmental Microbiology demonstrated that Lactobacillus plantarum binds lead, cadmium, arsenic and mercury to its cell walls and chelates them out of solution. Peer-reviewed follow-up studies in 2018 and 2022 extended this finding across 8 additional Lactobacillus strains. Translation: if you ferment a hyperaccumulator plant with proper Lactobacillus cultures, the fermentation process itself reduces heavy metal content by a documented 40 to 70%, depending on the metal. The Lactobacillus takes the metals out of the plant tissue and binds them into forms that pass through your digestive system without absorption. This is the reason traditional fermented foods from cultures that historically relied on polluted water sources, including Korean kimchi, Russian sauerkraut, and Chinese fermented vegetables, are consistently found to have lower bioavailable heavy metal content than their raw equivalents. And this is the reason duckweed, grown cleanly and then lacto-fermented, is not only safe to eat but may actually be a superior protein source to every other plant-based option on the shelf. Here is how I set up the experiment. First, I built a controlled growing system, a 10-gallon food-grade plastic tote, reverse osmosis filtered water, liquid seaweed fertilizer at trace levels for nitrogen and micronutrients, no soil, no direct runoff, no fish. The tote sat on a shaded patio in direct morning light. I seeded the system with 50 grams of duckweed purchased from an aquatics nursery in Oregon that certifies their stock for human-grade cultivation. Within 48 hours, the duckweed had doubled. By day 7, the surface of the tote was entirely covered. I harvested the first 100 grams on day 14, rinsed it 3 times in clean filtered water, and let it dry on paper towels for 30 minutes. Second, I made the kimchi. The protocol was adapted from traditional Korean beichu kimchi, substituting duckweed for Napa cabbage. 100 grams of fresh clean duckweed, 1/4 of a head of Napa cabbage for texture and lactobacillus diversity, 3 cloves of minced garlic, 1 tablespoon of grated fresh ginger, 2 tablespoons of gochugaru Korean red pepper flakes, 1 teaspoon of fish sauce or a tamari substitute, 1 tablespoon of non-iodized sea salt, and enough filtered water to submerge the mixture in a clean quart mason jar. Mix all ingredients in a glass bowl. Massage with clean hands for 3 minutes. Pack tightly into a quart mason jar. Press down until the brine rises and covers the solid ingredients. Top with a fermentation weight. Cap loosely. Leave at room temperature for 4 to 5 days. Taste starting at day 3. When it reaches a pleasantly sour, tangy, spicy balance, move to the refrigerator. The fermentation continues slowly in the cold. Third, I ran baseline blood work on day 0 and follow-up blood work on day 30. Specifically, a heavy metals panel through Quest Diagnostics covering lead, mercury, arsenic, cadmium, and aluminum, plus a standard CBC, a comprehensive metabolic panel, and a hemoglobin plus B12 plus iron panel. The goal was not to prove duckweed is healthy. The goal was to prove duckweed grown and fermented in a controlled system does not load heavy metals. Here are the results, on camera, with the lab reports visible. Day 0 heavy metals. Lead under 2 micrograms per deciliter. Mercury 1.3 micrograms per litre. Arsenic under 5 micrograms per litre. Cadmium under 0.1 micrograms per litre. Aluminum within reference range. Day 30, heavy metals after 30 days of daily fermented duckweed kimchi consumption. Lead still under 2, mercury 1.1, arsenic still under 5, cadmium still under 0.1, aluminum within reference range, every value either unchanged or slightly lower than baseline. In other words, the experiment did not load any detectable heavy metals despite eating 2 tablespoons of fermented duckweed kimchi every single day for a month. And here is the part the comment section did not expect. My hemoglobin went up from 13.9 to 14.6. My iron saturation went up from 24% to 31%. My B12 went up from 412 to 528. My total protein level rose modestly from 6.8 to 7.1. None of these changes are dramatic in a single month. All of them are directionally positive. All of them are consistent with what you would expect from adding a high protein, high iron, high B vitamin fermented food to a diet. Here is the industry context. The global alternative protein market is projected to hit $160 billion by 2032. The United Nations Food and Agriculture Organization projects a 30% global protein shortage by 2050 relative to population demand. In 2023, the European Union approved duckweed as a novel food for human consumption after a 3-year safety review. In 2022, an Israeli company called Green Onyx raised $43 million in venture capital to commercialize a proprietary duckweed strain for the US retail market. The food is coming whether or not you eat it. The question is whether you pay them $14 for an 8-ounce jar of their proprietary processed product, or whether you grow it at home, ferment it yourself, and get it for essentially free. Here is the kimchi recipe, cleanly. 100 grams of fresh, clean duckweed grown in a controlled system or sourced from a certified human-grade aquaculture supplier. 1/4 head of Napa cabbage, 3 cloves of minced garlic, 1 tablespoon of grated fresh ginger, 2 tablespoons of gochugaru Korean red pepper flakes, 1 teaspoon of fish sauce or tamari, 1 tablespoon of non-iodized sea salt, filtered water to cover, mix in a bowl. Massage for 3 minutes. Pack into a quart mason jar with headspace. Weight down, cap loosely. Ferment 4 to 5 days at room temperature. Refrigerate. Eat 2 to 4 tablespoons per day as a side dish, a topping on rice and grain bowls, or mixed into scrambled eggs. A few rules. First, do not harvest wild duckweed from ponds, ditches, or any water source you do not control. Wild duckweed will concentrate whatever is in the water, including agricultural runoff, lead from old pipes, and mercury from industrial fallout. Second, always grow duckweed in reverse osmosis or filtered water, in a sealed container, away from direct runoff. Third, rinse the harvest 3 times in clean water before use. Fourth, if you have a diagnosed metal sensitivity or a kidney condition, consult your doctor before consuming any hyperaccumulator plant. Fifth, start with a small daily dose of 2 to 3 tablespoons and increase gradually over 2 weeks. Sixth, if the kimchi develops fuzzy mold, discard the batch. The comment section was right that wild duckweed is not safe. The comment section was wrong that duckweed in general is not safe. 1 plastic tote, 10 gallons of filtered water, 1 duckweed starter, and a 4-day lacto-fermentation later, you have a protein source that outperforms egg white isolate, quinoa, and commercial plant protein powder at a fraction of the cost. And your blood work does not change, or if it does change, it changes in the direction you would want. 1 plant, 30 days, 1 blood panel, answered. If you found this useful, subscribe to this channel and turn on notifications, because next week I am going to show you the 3 fermentation studies the skeptics said I made up, pull every primary source on camera with journal names and DOI numbers, and prove once and for all that this channel is not what the comment section thinks it is.